All right, guys. Now we're getting into separation of variables, and absolutely on the AP test, absolutely on my test. We're doing page 364, number 4, 8, and 21. So the trick to these is there's going to be questions on the AP test, and if you don't separate the variables, and all that means is get one variable, the x on one side and the y on the other side. If you don't do that, you have a chance at getting 0 points on these problems. So the first thing you want to do whenever you see a problem like this, when it has this and they're asking you for an original function, so our end result on this one is an f of x. And we know that because it gives us an initial value and it gives us a derivative. So you're going to separate the x's and the y's. So keep everything over on the right side except for the y's, and then move the dx over to the other side too. So in one step, we're going to go dy, we're going to divide by that y, and then we're going to multiply by dx. So we get 2x dx. All right, so then we take the antiderivative of both sides of this. This gets us the antiderivative of dy over y is the natural log of y. The antiderivative of 2x is 2x squared divided by 2 plus c. So we get the natural log of y equals x squared plus c. So now what we can do is we can plug this in, and we get we're going to figure out what our c is. So we get the natural log of 3 equals 0 squared plus c. So our c ends up being the natural log of 3. So we come back up here, we got the natural log of y equals x squared plus the natural log of 3. Okay, now we want to get this into f of x form. We can't just leave it like this. This will get us part of the points. We'll get 3 out of 5, 4 out of 5 on some problems. So you got to look at this, and we have to actually solve for y. So the way to solve for y is to rewrite this without using log form. We rewrite it in exponential form. So this is our y equals, the base of this is an e, so we just raise this to e. Okay? And then free response question, totally acceptable answer. But on a multiple choice question, they're going to expect you to know that this is y equals e to the x squared times e to the natural log of 3. And the beauty of e and natural log is they cancel each other out, and this just becomes a 3. So our answer is y equals 3e to the x squared. All right, and so our answer is 3e to the x squared. Definitely know how to do these problems. They're going to come up left and right, and they're going to sneak up on you. So we get this problem. Once again, we're going to use the same exponent rules that we used up in the last problem. So we have dy dx equals e to the x minus y. So if it's x minus y in the exponent, that is just e to the x divided by e to the y. So now it's much easier to solve this. We just multiply this side, e to the y dy, and this is going to be e to the x dx. We take the integral of both sides. This is going to give us e to the y equals e to the x plus c. We want to figure out what our c is. So e to the 2 equals e to the 0 plus c. This looks like it's going to be e to the 0 is 1. So we get e to the 2 equals 1 plus c. Subtract 1. E to the 2 minus 1 equals c. So now that's our c. We got to plug that back into the original equation, and we get e to the y equals e to the x plus, what did we get? E squared minus 1. Alright, now, can't leave it like this. We have to solve for y, so we just take the natural log of both sides. And this is going to give us y equals the natural log of e to the x plus e squared minus 1. And we're done. That's a perfect answer right there. Alright, moving on to our last one right here. I believe this is a word problem. Let me turn to the book quick. 364. Okay, so this is the word problem number 21. Its half-life. The radioactive decay of SM-151, an isotype of samarium, can be modeled by the differential equation dy dt equals negative 0.0077y, where t is measured in years. Find the half-life of SM151. All right, so we're going to look at this. We got dy and we got dt. So we're going to move this y over here. So we got dy over y equals negative 0.0077, and then move this dt over there. Take the integral of both sides, and we get the natural log of y equals negative 0.0077t plus c. We raise both of these up to e's, right? So we're going to raise both of those up to e's. We get e to the natural log of y, which gives us y equals e to this. So we've done this plenty of times. We know if this is going to be in the exponent right there, we know that that's just e to the c, which is just some constant, c, and then e to the negative 0.0077t. All right, so because we've done this many times, we know c is our initial amount, y is our amount after time. So the beauty of half-life is that no matter how much you have to start off with, you always have half at the end. So if you started off with 100 in c, then this would be 50. If you started off with 1,000,000 in c, then this would be 500,000. So just start off with 2 and make that 1, and we'll get 1 equals 2e to the negative 0.0077t. We divide by 2, we get 1/2 equals e to the negative 0.0077t. Take the natural log of both sides because that's going to get rid of this exponent. We get the natural log of 1/2 equals negative 0.0077t. Divide by negative 0.0077, negative 0.0077. And I'm good, but I'm not that good. I would use a calculator to do this. So I got the natural log of 0.5 divided by negative 0.0077, and we get 90.019, which is approximately 90 years. Okay, started out as a super hard looking question, ended up being a nice easy answer. All right, practice. If you have any questions, let me know.